they also conduct fundamental research. And the university part, of course, it's mostly concerned with publication and dissemination of knowledge. And then there's the second entity, Wageningen Research. There are 9 research institutes within this. Here we basically do applied research and industry-driven research, and also contract R&D. Although we are not for profit, and we do not receive any funds from the Dutch government itself, like the research part. So how do we get funded? It's through the projects that we do for our clients. So it's basically R&D that we get paid for. So let's say you're a startup or a company who has just entered the alternative protein space, or you've been working in this space for quite a while, and you're looking to develop or co-develop a product with us. Then you come with your ideas, and then how do we actually turn that into a project? This is a slide that kind of describes that. There are 4 steps involved, and you have a very experienced team at your disposal. And kinds of terms that you'll be hearing include a BD, which is a business developer, that's what I do, but also like a program manager and a project leader and the scientific team themselves. So when you first come with your idea, let's say the program manager checks to see if we are free to operate in this area, and the project leader checks to see if we have the right expertise to do a good job in this project. And then if we all agree that, okay, this is an idea that we would like to take forward, then we go ahead and start framing a proposal for the client. And of course, at this stage, we have a lot of clients, interviews, and a lot of meetings back and forth to make sure that your needs and the functionalities that you're looking for in a product are rightly described. And each proposal, of course, we describe the objective and the kind of approach that we're going to take to deliver the results for you. But we also give you like a budget for the project that we do, and we define the terms under which such a project can be determined. And once we also agree upon the project proposal, let's say, and the client is happy with what we've made for them, and we then make an offer. So there is a different contract for it. And once the offer is also signed, then I transfer basically all of the ownership to the project leader. And then the project starts exactly then. And then during the course of the project, we evaluate if we are adhering to the deliverables and if they're happy, if the customer is still happy. Is it that simple? Of course not. There is also a lot of documentation that goes into this process. For example, even before we start, exploring the idea, there might be some commercially sensitive information that you don't want to reveal. So we might sign a non-disclosure agreement. And then we start with the initial project concept, which finally is turned into a project proposal when we make the offer. But also there is a term sheet. Just open everything. There's a term sheet that I also share at the stage of the proposal itself, and this is a very general term sheet. For example, it includes all terms regarding to confidentiality, IP, publications, and liability, and all sorts of other contractual terms. And these can be customized into specific terms and conditions for that specific client's needs. And once we get all of these approved by the customer, we turn all of the documents into 2 final documents, a project plan and a contract that is signed. And it's only then that the project starts. So you can see there's a lot of steps before the project even starts. And then let's say we of course, you might be also interested to understand what is the trajectory of a usual project development project. It all depends on what kind of background research that you've done and what technologies or scientific expertise you have in your team or startup. Mostly, probably generally what you want. Like maybe you want like a plant-based milk or a meat alternative, or perhaps you have some microbial or fungal strains or resources that you would like to explore and see if you can extract any alternative proteins from it. But you probably also have like 1 or 2 project ideas that you would like to explore. So, and then what if you don't actually know all of this, and you don't know what kinds of ingredients that you would like to put into your product, or what functionality you want in your product? Then what we actually suggest is to go for a scoping study in phase 1. And as you can see, there are 2 steps in the scoping study. The first one is to use what we have, an Innova database. Basically, it's a list of all of the products that are released worldwide. The list is less intensive for India and other emerging markets. But basically, it gives us an idea and a trend of the products and the market growth of these products. And once we make like a long list, we go to the next step of co-creation with clients, where we try to shortlist and define the product in exact terms and in detail. And once that phase is accomplished, we move on to the actual experimentation, or the phase 2, what we call as prototyping. And we might actually further divide it into also like 2 parts, like the initial prototyping, where we do some preliminary experiments. And if the client is happy, or if they would like to change their approach after the initial results come in, then we can also go for, accommodate for those changes and then go for the final prototyping. A little bit more on the Innova database that we have. This is actually something that we pay for every year, and as a research institute, it's quite important for us to keep up to date with market trends. This is, for example, a short snapshot of the market insights that we get from Innova as well. For example, it gives us insights into the ingredients that go into each product, not just protein, but also if you want the correct functionality, there's probably some fat, and there's some carb sources, all sorts of ingredients that go in there. But also we look at the percentage changes in the market trend and what is the growth of each of these markets, so that we are at the cutting edge of innovation. We understand where the innovation is happening. And probably also Laurice will talk about the new and emerging protein ingredients and how she uses Innova insights for that. And a little bit more on innovation and IP. For example, when we start with a project proposal, we make a budget for you. And this budget covers just the R&D and the personal costs only. And IP is by default in the name of our research institute. And also by default, the client also receives a right to results that are non-transferable, as in you can use them, you cannot transfer them to a third party. Non-sub-licensable, like you cannot license out and get any profits out of it. And it's non-exclusive, like we can also give the same, let's say, product formulation to another client. And this, at first glance, it might look actually as something that doesn't make sense. But if I may expand, market positioning, can be captured by reducing your input costs instead of paying the same cost for IP. So in that sense, you can also have other business models that give you market positioning and market capture. So not all clients are interested in buying IP. And at the same time, IP and filing for patents is quite expensive. And if your market is not as big as you wanted, then probably it's not the right strategy for you. But another way to actually transfer the rights to results to a client who's actually interested in owning all of the rights is to maybe very narrowly define the field of use, as in it could be plant-based milk, for example, and for a specific geography, like for India, if you're an India-based client. And this would very much bring down the cost of buying such IP from the university. And maybe I'll also talk about the IP models a little bit more if needed during the Q&A. Also to give you a very realistic idea of how a project looks end to end, what are the different steps and the usual timelines of a project, I would like to describe one of the projects that we've done and also ended just recently with an Indian client. So first contact with this client happened in Jan of 2019. The client came to us with 2 different project ideas, and we made 2 different draft proposals for their review. And then around Feb, the client decided that they'll go ahead with one of the projects and that the second project will be on hold. But as you can see, between March and May 2019, It took us 3 months to understand the term sheet and negotiate the IP and the contractual terms, and before the agreements were finalized. And then at around June, the payments have occurred, and the project was started. And of course, immediately in July, there was a summer break, so nothing happened then. And in August, we started with the phase 1 of Innova database study. And just so to give you a little bit more background about this client, so this is a client who was not in the agri-food space before. So this was a completely new venture for them. And they basically didn't have a background in food science or agri-related topics. So this was also the part where we were guiding them all the way through. And we started with a long list of both ingredients and technologies, which we then shortlisted along with the client. And of course, the final report was made with the recommendations that we made to the client. And after about 3 months, we got the go-ahead to phase 2 when the experimentation has started. And we had some difficulties in sourcing ingredients. And also, of course, the client was quite flexible in co-sourcing the ingredients with us. It also happens that with Indian clients, if they would like to use protein sources that are available in India, then they maybe ship it to us and we use those ingredients actually to do the experiments. And then we moved into the summer period when we had the first experiments of the first phase 2A, let's say the initial prototyping. And the results were found to be quite innovative, and we've presented to the client very positive results. And then, of course, the client was very much interested in buying the rights and the IP. And then we moved ahead and we prepared what we call as the invention disclosure form. So this is what we prepare describing the invention itself to an IP firm, so that the IP firm can check what is called as the prior art. So this is just to check basically if anybody else has done work in the same field. And then we, after a month, got the results that it was both possible to patent it, but also there is freedom to operate, by which we mean that we are free to work in this area. We are not infringing on the IP rights of any other company. And then it took us another month and a half to prepare the IP transfer agreement. And at the same time, the second phase of experiments continued to prepare the final prototype. And as of today, the final prototypes are ready, and we are wrapping up the project with the final reports. And of course, the client is so happy. So we've also spoken about the second project, and now we are planning on starting it in December this year. So you can see it's a very long timeline from an initial idea to a final project. You can expect something between a year to 2 years, practically speaking. So there's no quick solutions. There's no product developments that can happen in like 3 months to 6 months to 9 months, especially if you're starting from scratch. Maybe if you're a company that has done like initial studies, then maybe we can do like part of those studies or improve the product in a few months. That's still possible. And of course, I mean, also to focus on the international collaboration part, right? So we talk about what are the facilitators or barriers and how to make sure that this happens smoothly. First of all, because there's an R&D project, it's very important that all partners are dynamic and they're adapting to the upcoming results. And as and when the results come in, they probably will change their approach. You understand that there are risks involved in R&D project, and that nothing can be guaranteed at the beginning. We aim the experiments to deliver what we say, but also like we need to experiment in order to find out what the final result will be. And also culturally, working with the Netherlands, it's more of a co-creation rather than a client or a customer sort of a relationship. We do appreciate very much open and friendly communication. And especially if you're a newcomer, it's very important that you are open to receiving feedback and you're quite coachable. And we are very much happy to give you all sorts of inputs that you need. And also for a market like India, where technologies or probably the ingredients are not readily available and there's no turnkey solutions, we do try to cooperate as much as possible in order to come to a common vision. Finance-wise, also because people keep asking me this question, so I thought I should just put it out there. Based on the simplicity to the complexity of a product, it could be anything between 65 to 200k euros. And this is just the product development cost. There will be other costs for IP, but that will only be determined based on the market value. Patent filing can be costly as well if it's just for European or just for some specific markets, geographically limited. It could be starting from 5k euros to a worldwide patent for around 50k euros. So it's very important for you to understand your market and to see if your market is more valuable than the patent costs. And as I said, there could be some geographic focus to reduce patent costs, but then if you don't want any infringement risks in the future, maybe it's a good idea for you to buy the IP rights. And now coming to the million-dollar question, that sounds really expensive, right? I know I've been working with India for almost 2 years now, so how do we make this work? Well, we are also trying to mobilize the community and the ecosystem to make this easy. We are looking at Indian grants to see if there can be specific grants that can be subcontracted to the Netherlands to do specific research. But also there are some Dutch grants where we have call for partners, and these are regularly and periodically updated on our website. And then if maybe you can afford a part of the development costs, there could be some public-private partnership consortia where the IP rights can be given to you based on the percentage that you contribute. And of course, I think because these are expensive projects, if you're not able to raise the finances itself, there could be investors that we're very happy to also include in our discussions and show them how we are mitigating risk. And also, I have to say, if you're really going through the investor route, then probably buying IP is a good way for you, because that sort of de-risks the entire project for them. And maybe at incubation centers, most of the entrepreneurs will be hearing about it. So yeah, I've come to the end of my presentation, and I'll hand it over to, I don't know, maybe Shardul or Laurice.
Yeah, I'll just quickly bridge in, and actually I'll invite Varun to also add in some context on that really nice presentation where you've raised a lot of important questions that usually people ask to us in terms of going on about collaborating with the research lab internationally. And I think those timelines, some context setting around the cost, all of that has really helped. Varun, would you like to quickly chime in?
Yeah, thanks, Shardul. Thank you so much, Swathi. So the reason that I wanted to chime in here is just to highlight a couple of the things that Shardul said. So we've been trying to stimulate the entrepreneurial ecosystem and the product development ecosystem, Swathi and Dr. Pouvreau, for the last 2 years. I think one of the major things that we can do to get the velocity of product launches moving faster is to bring in product development experts. So for everyone who's in the audience, thank you so much for joining us today, by the way. The thing that Swathi outlined, which is really important here, is in a market like India, the major thing is entrepreneurs seem to be hamstrung by a lack of ingredients, product development expertise. There are many pieces of an ecosystem that are still being built. And I talk to the students, the entrepreneurs, a lot of the folks that are engaging with us all the time. And sometimes the frustration is palpable, right? In terms of we're getting a lot of excitement, but people cannot actually bring products to market. So it feels like the progress in the ecosystem can be a little bit superficial if we're not seeing products in the market. Now, obviously, when we're talking about how we can shortcut that, capital and the expenditure of that capital is one of the first things that comes to the fore. But even if you have capital, you need partners that make a lot of sense, which is why we think that Wageningen University, for the entrepreneurs we've been advising, engaging with, etc., we've been making introductions and will continue to do so because Wageningen University and Research is quite possibly the best university in the world, the best academic and research center in the world to do any of this kind of work. I mean, I say quite possibly, the rankings say it is exactly the best. It is the #1 place in the world. So if you're an entrepreneur in the audience, especially the ones that we already engage with, or if you need some sort of conversation going with Swathi and team, we'd be glad to facilitate that. We will also be, of course, sharing the details and moving it forward. But I can say that from all the experience I've had working in this space for several years now, if you indeed are decided about innovating in this space, whether it is with Wageningen or anyone else, you should probably not wait around for product development teams to materialize out of nowhere, because they will not. You will need to engage with someone like a Wageningen University. Just to round out what I'm saying, we have multiple relationships going across India and the Netherlands, because there is this very important ability to transfer technology and to create momentum in our market in a way that will not happen spontaneously on its own. The Netherlands being a leader in what's known as the protein shift is something that we're trying to build relationships across this, what we're calling a protein corridor, a smart protein corridor. So Wageningen University is one of those fantastic organizations. Another one is called the Protein Cluster, Food Valley, and of course the Embassy of the Kingdom of the Netherlands have enabled a lot of this work already. A couple of things that we're doing moving forward is we are partnering with the Protein Cluster and Food Valley Netherlands on their own summit, which is taking place on October 13th and 14th. We also have Swathi and Dr. Pouvreau's colleague, Dr. Stacey Payette, who is speaking at our own summit, the Smart Protein Summit, on October 6th to 10th. And you can check that out at smartproteinsummit.com. More details will be added, but you can go ahead and register right now. I'll leave that there for now, but there's a ton of really exciting stuff coming with the Netherlands, is all I'll say. So I'll hand over back to Shardul. Thank you so much for that time.
Thank you, Varun, for that context. And I think we can just take one question before we move to Dr. Laurice, which is pertinent to what Swathi presented. Swathi, would you just like to maybe reiterate or clarify what type of proposals, like collaborative, individual, academic, and at what stages, proof of concept, minimal viable product, etc., are supported by, through this initiative? And maybe could you also throw some light on what kind of clients usually approach you? Are they like individual entrepreneurs or bigger corporations? Or if you could just give some profiling around that, I think that would help the audience and people who will watch this recording as well reach out to you a little better.
Yeah. Just so that I understand your first question better, you want me to expand on what kinds of like funding mechanisms are present, right? Like the PPP consortia that I was speaking about. Is that correct?
Yeah, that could be one aspect. The other would be what is the nature of these collaborations? Is it just academic? Is it with industry? Is it a mix, hybrid? Maybe you could talk about some of the models of collaboration. And then at what stages would a client usually approach you? Is it right from the start, or can they also approach you maybe after they've already have a POC in place to improve upon it, etc.?
Yeah, so it's really varied. I mean, all of the work that we do is basically with the industry. We are a contract R&D organization, so we usually really don't do product development for academic purposes. I mean, we do have some strategic calls, for example, like 3 or 4 year calls. Maybe Laurice will tell you more about it. Also, like for some technologies that are really early stage in their innovation. And usually we see that also, like the sorts of companies that are interested in these PPPs are the really big ones, right? And I hope that answered your first question. The nature of the collaboration, of course, it's very industry driven, and the ultimate goal is to release a product or at least an initial prototype for a client. And the types of clients that we have, it's a mixed bag, actually. I mean, we do have like really big companies who have done like a POC and then have come to us probably to improve their texture or to answer specific questions about shelf life, or to improve the flavors even in some cases. I'm also like specifically talking about India, right? Maybe Laurice can expand on it. But also we've worked like the use case that I've shown to you, that is a startup, it's a 2-member team, like there was nobody else in the team. So they came to us saying, okay, we would like to enter the space. We know that it's quite emerging and it aligns with our values. So how do we go about it? So it's all kinds of clients that we get.
I think that clarifies it really well. And I think audience will have some questions as a follow-up on your last slide around how can we better use the existing infrastructure, some of the funding and grants considerations. We can get to that in the last leg of the Q&A session. I would now invite Dr. Laurice to go on ahead with her presentation.
Yeah, can you all hear me?
Yes.
I'm trying to put my presentation on the slide. Yes. Good afternoon, everybody. I'm very glad to be here talking about the protein transition and our effort around developing or increasing the use of plant protein in the world. Just a few words to introduce myself. As Shardul already mentioned, I'm a protein scientist by background, and I've been working for the last 20 years on plant protein. Still very excited by this field and by the field of new and alternative protein sources that we are going to talk about today. I hope you will understand my French accent, by the way. Sorry for that. I try to divide my presentation in three major parts. So one is, how do you choose the right protein ingredients for the right applications? We'll talk briefly also about the plant-based dairy alternative, which is a booming market in Europe and all over the world. And on the last part, I will talk about different technologies that we have, which are possible to use to actually structure plant protein towards the meat and alternative market. I have to make this one smaller. Yeah. So when we are talking about the plant protein market, we are really having a broad view. We really strongly believe that there is room for every type of protein to be used in food applications. So you can think of the still established proteins, so animal proteins still have a room in our food, and we should not stop using them. But you have also the cereal and the grain, which have been used for many, many years. So you can think of the wheat, of the corn, which have been used in food product for a very long time. What we call the emerging, even so some of them are used in food application for already quite a long time. You can think of soy, of the legumes protein, so the pea and the fava bean, which are coming up, but also co-product protein. And from that, we are thinking of the potato protein, which are extracted from the potato juice, while they are actually extracting the starch. But you can also think more recently of extracting protein from the sugar beet leaves. A company in the Netherlands, Cosm, as actually is in the planning of launching a new ingredient from sugar beet leaves. And we are very excited because we also participated in the development of this extraction. But we are also not forgetting new source of protein. And from new source of protein, you can think of fermentative biomass. We really strongly believe that there is a new space coming for protein which are extracted from a microbial biomass. You can, of course, think of the macroprotein, which are from fungi, but you can also think of really microbial from bacteria, which are extracted. And we strongly believe that there is room for this type of ingredient for creating new structure and new food product. On the side of this thinking, we are also seeing trends into the insect protein in Europe as well, and on the microalgae, micro and macroalgae, but also, for example, the duckweed. So all the aquaculture source of protein are so far very underutilized in the world, and we really believe that new technology are necessary to make the most out of this source of protein as well. What I want to stress in this first part is that not every protein ingredient can be used in all type of applications. So every ingredient, every protein is unique. And it's something that you have to keep in mind when you are trying to replace one ingredient by the other. It's not that straightforward. For example, what we try to show in this table is that if you are aiming at a beverage type of application, of course, the solubility of your ingredient will be crucial. But if you are thinking of a meat alternative or even a pasta or baked goods, a cookie, solubility is not your key interest, and it can actually be to a detriment of the final application you are looking for. So what we are trying to say there is that Every ingredient will have in applications, but you just need to find the right one for it, and vice versa. Within Wageningen, of course, when we are looking at food product, we are going from the top down, but also to the bottom up. So we are looking at proteins on a molecular level. So what is the structure? How do they behave upon different conditions? So salt and temperature, for example. And upon temperature, for example, how do they form aggregates? And how these aggregates rearrange themselves in a 3D structure to be able to form your food matrix. And of course, once you have this food matrix, what is very important is what is the structure and texture of this food matrix, because this will influence the perception you will have when you eat your food. So it's also very important to link the structure of your food and the texture of your food to the mouthfeel of the food while consuming it. So we are able to actually look at all these different aspects within the formulation and the making of a new food product. This is just a very quick example, just to really shortly show you that every protein ingredient is unique. And if you look on the left side of the screen, this is an example of soy protein isolate, and their solubility of different pH. You can really see that you have a huge variation in the solubility of the ingredient between. It's the same composition in principle, but the processing condition of the ingredients will have a huge impact on the solubility and on the applicability of your ingredient. So processing history is key for application in food products. This brings me to the plant-based dairy alternative. And when I'm saying plant-based dairy alternative, you can think of a milk replacer, so a plant-based beverage with fat in it. You can think of yogurt type of application and of cheese type of applications. In all these applications, the solubility is rather important, maybe a bit less into the cheese and the beverage, of course, but still you need particles which are below the 5 micrometers, which will at least prevent the perception of these insoluble particles. So it's very crucial for the mouthfeel of the food. Of course, in all these products, you also have fat being present. So the emulsifying properties or the ability of the protein to be able to stabilize the oil droplet is also very important to take in account. For a plant-based beverage, you want an ingredients which do not aggregate or do not change too much upon heating. And by heating, I mean pasteurization or sterilization, which are required for, of course, making for food safety reason. So you want something which stays stable upon heating. For the yogurt and the cheese application, you actually want something which would be able to form a gel, so to form a structure upon heating or upon acidification, in both cases actually, where you have a reduce in pH during the ripening or during the acidification, the fermentation process for the yogurt. So what is important to take in account is that you want to be able to modulate the functionality of the proteins that you are using. Oh, I see something popping on my screen. You want to be able to mimic the texture and the stability of the products that you are aiming to mimic. So in this case, if you want to mimic a yogurt, you want the same texture. So you want a smooth and soft gels, which contains fat. And for being able to achieve that, you have different strategies. So you can think of using different mixture of protein. You can also, of course, look at the protein oil interaction. So the interfacial properties there are very important. But of course, if you look also at plant or dairy alternatives on the market, you can also see on the labels that they are also using carbohydrates. So you can think of polysaccharide, at least hydrocolloid, or modified starch, for example, to be able to achieve the texture that you are looking at. So it's also very important to understand what are the interactions between the protein and the carbohydrate. So it's, again, trying to make a process in which you are able to control the interaction of the protein with its environment. So the fat, the salt present, the oil, sorry, I already said that, the carbohydrates which are also present. So it's very important to be able to control this condition and to be able to have a product with the right structure, texture, but also that this process is robust enough that you are actually always obtaining the same product quality. One of the things, especially in Europe, which is very important while you are making food product with plant protein, is the taste and aroma. In the Western world, we are still not really used to the soy of at least the taste and the flavor perception of plant-based protein. So it's also something that you need to take in account in your product formulations, as what kind of flavor needs to be added or what kind of processing steps you need to apply to prevent the formation of a flavor. What for some of our customers is also very important and where we can help, especially if you are looking at protein mixes, is being able to match the nutritional value. And by matching, it's either matching to the products that you want to mimic, or is having the same, the right amount of essential amino acids which are required by the FDA. So it's something that we are also helping our customer to find the right balance of ingredients to have the right nutritional value. I cannot, oh, yes. When you are talking about emulsifying properties, what is very important and is that in this case, the protein has the ability to actually, upon shear and heat in some case, is to be able to go at the interface between the fat and the water. So it needs an hydrophilic and hydrophobic part. And it's the ability of the protein to stay at this interface and to be able to stabilize the oil droplet and to actually have negative charges on the outside to be able to actually repel each other, that you don't have any aggregation of your oil droplet or coalescence of this oil droplet. So it's very important to be able to, again, knows what ingredients you have at hand to be able to design a product which will be stable, because of course if you are designing a plant-based beverage, for example, you don't want your product to cream immediately. You want it to be stable, at least especially if you are looking for a sterilized product. You want to have it stable for a year. So you need to have a good emulsifying capacity of your protein, or you need to add ingredients to make it a stable emulsion. When you are talking about gelling properties, and gelling properties are crucial for yogurt or for cheese applications. And it will also be very important for meat alternative as well. The gelling properties is the ability of a protein upon heat most of the time to be able to actually form a 3D network. So to be able to form aggregate, to unfold upon heat, sorry, and aggregate with each other to actually form a 3D network. The structure of this 3D network will be depending on the pH of your product that you are aiming for, the salt concentrations, and other ingredients such as polysaccharide or hydrocolloids, which will also have some interaction with the protein. So again, depending on the type of product that you want to aim at, if you want to have a gummy bear, you want a more transparent type of gels. So in this case, it's very important to stay far away from the isoelectric point, for example, and in general to have a low ionic strength to be able to have a transparent gels. If you are aiming at a yogurt, it's of course an opaque gel, it's a whitish gel that you are aiming for. In this case, the salt addition or being closer to the isoelectric point will actually help you to achieve the right structure and texture of your final product. So it's very important to understand, again, what kind of protein you are working with and how do they aggregate and form a network upon the conditions that you are applying. This is just a very short example, a small example. As I said, most of the protein gels will be heat-induced gel. So at high temperature, you can think of whey protein and soy. They unfold from aggregates, which rearrange to larger aggregates, and at the end form a protein network. Gelatin, for example, is also a heat-induced gel, but the other way around is that it's actually making a protein network upon cooling. It's soluble at a high temperature. When we are thinking about cold set gels, it's actually a protein solution which actually have been actually heated, but in conditions which do not form a gel, and by actually either acidifying the product or by the use of enzyme like the rennet in cheese making, or by the addition of minerals like calcium in tofu, that you are actually able to, after the heat treatments, to actually form the protein gels. And in some cases, this is also an example in which we have experience is that high pressure can actually help you to form a gels. And what I want to show with this slide is that actually every protein is unique. So once you have chosen a source of proteins for your product formulation, it's very important to understand how this protein actually behaves in different conditions. This would really help you to actually develop the right product. This is an example of an acidified gels, and the aim of this study was actually to replace part of the sodium caseinate by soy proteins. Also, again, going there, it's more a mixed product. But what we saw is that actually just replacing 3% of sodium caseinate by 3% of soy protein, you get a different texture in terms of structure, but you also get a different firmness of your gel. So how do you actually achieve or go back to the original properties of your gel? And what we found out there is that the co-processing of the ingredients before the acidification was crucial to be able to actually achieve the right structure and texture. And in this case, heat treatment of the two proteins together and applying a very specific pH really allow us to be able to achieve the right structure and texture of the food. So again, very important, processing condition and co-processing of the ingredients will really help you to formulate the right product. Oh, this is animated, I didn't know. We'll go very quickly on that. This is a study that we made in one of my former projects, where we show that the gel coarseness is very important for the water holding capacity. And by water holding I mean the amount of water which are actually in the pores of the gel, and how much of this water is actually also going to be expelled while you are chewing your food. So it's actually very important for the juiciness of your food product. And what we found out there is, again, that the coarseness is not the only determinant of this water holding capacity, that also the firmness and the elasticity of your gel, and by elasticity I mean the amount, the resistance of the gel upon the compressions. So for example, if you have a gelatin gels, you can compress whatever you want, no water will come out because it's a very elastic gel. But the soy protein is a little bit more brittle, so it will be able to expel water upon compression, and by compression you can think of mastication, so when the food is actually going to go in your mouth. So again, very important to design the right structure to be able to have the right juiciness and appeal of your food product. I already touched upon quickly this, the off-flavor of plant protein. As I mentioned, and I would expect that maybe in India it's a little bit of a different perspective, because the way we perceive the off-flavor of plant protein is very geographically dependent, in the sense that in Europe we are not used to it, or at least it's coming, but it's still not yet there. But we are not used to eat as much plant ingredients that maybe in Asia it is the case. So the flavor composition for us and the flavor perception is very important. So, for example, we don't necessarily like the beanie flavor of soy. We don't necessarily like the green beanie hair-like type of flavor from the pea protein, and also the bitterness and the astringency is very important. At least a negative point for these ingredients. We know which compounds are associated with this soft flavor because we actually have a flavor department in our group. So we know it's coming from the aldehyde and the pyrazine, which are actually present in the ingredients. And also the bitterness and the astringency can come from the saponin. So we know this, and we have actually one of these consortia projects, which is called Pulse, for off-flavor and functionality, which actually aims at looking at processing conditions which can limit the formation of this off-flavor, and also which of the pre-processing of the ingredients will help, for example, to have a lower amount of saponin, which can be detrimental to the flavor. And we also have the tannin, the removal of the tannin, which is also taken in account in this project. This is more from the agricultural side. This is an example of the saponin content between different cultivar or soy protein. What you can see on the bottom here in the graph is that depending on the cultivar, you will have quite a huge differences in the amount of saponin which are expressed by the plant during the growth. And of course, if you look at cultivar 2, it seems that it would be a better candidate for food application since the saponin content is lower. What you also need, and I think it's very important while you want to develop an ingredient with soy protein, is taste your ingredient. And believe me, I have tasted some very good plant protein ingredient, but I also have tasted some very bad one in my life. And it's but it's very important to taste the ingredient just in water to get the impression of what is the flavor and taste profile of the ingredients. By doing so, you will be able to screen ingredients and have an idea of how these ingredients will behave in your food formulations. If you have a bad ingredient from the beginning, it's much more difficult to actually mask what you want to do so at the end. And it's better to start with an ingredient which has a better quality from the beginning. This brings me to the third part of my talk, which is on structuring plant protein towards meat alternatives. We strongly believe that it's really part of the whole protein transition that we see and that we promote, is that there is a need for consumers to be able to consume meat substitute in the world to have a more sustainable world in general. And we see this trend. We see an increase in the market of plant-based alternatives, but we don't always see a strong decrease in the consumption of meat. So we believe that there is a need for, and don't get me wrong, it has really improved in the last 10 years, the quality of the meat alternative that you can find on the market. I think a lot of also big and famous companies like Beyond Meat or Impossible Burger have promoted also these trends in new product. So there is a lot of improvement, but there is still room to improve further in the sense that we still get from consumers that meat alternatives are not as juicy, that they don't have the same mouthfeel as the real meat. So it's very important, we believe, to improve the structuring ability, or to better understand the structuring ability of proteins, but also to make this product even more sustainable is to be able to actually use different ingredients. Wheat and soy are really dominating in the plant-based alternative, meat alternative. But also to make more use of less refined ingredients. Most of the time right now we are using protein isolate to make meat alternative, but we are really trying to promote and to find ways to be able to use more concentrate or even flours into this product. So what we are still working on, and really, and I will go in the next couple of slides more around that, is the sensorial qualities of the meat alternatives, so the texture, improving the juiciness, improving the flavor of this product, so the flavor during mastication, so what is the flavor released upon mastication, and the diversification of the protein sources, less refined ingredient, and the impact of secondary processing. I will shortly go through the different technology which are used in the food industry, and technology which are upcoming in this area. When you are talking about mixing, forming, and combining ingredients, it's still one of the most used to actually develop a new meat alternative, and it's really, you can think of burger, meatballs, or sausage if you have a lot of fat in there as well. And it's really widely used. It can really give you very good sensorial properties, and it's usually easier to develop in the sense that you don't need necessarily the fibrous structure, so you are not looking like having the fibrous structure of a steak or a chicken. So it's a little bit easier to develop. It's using quite conventional food technology, and the selection of ingredients are relatively broad. For example, in the burger, you will use texturized vegetable protein quite often to actually make them, and you will use ingredients to be able to make a glue, at least to glue the TVP together. Fermentation, in a way, and the use of microorganisms for meat alternative. It's in some cases, like for example for tempeh, it has been there for centuries, I believe, in Asia. But the use of microprotein, for example, is a relatively more recent market or newcomer in this area. You can think of corn in UK, a UK-based company. And in this case, it's really using fungi to be able to produce microprotein for the application in meat alternative. These ingredients have the beauty that the protein is already kind of looking like a fiber. So it's already giving you the fibrous structures that you are looking for application in meat alternative. So it has this big advantage. Microprotein by themselves are not glued together, so you also need to add in ingredients to be able to glue together. Quite often, it still use egg white proteins to be able to stick these microprotein together. Or in more recent years, for example, you have the use of potato protein actually as a glue in between. What we are working on in this area is really about the functionality and the nutritional value of these ingredients. But what we are also looking at is fermentation for vitamin, for example, for specific vitamins or specific mineral in these microprotein or biomass sources to be able to increase the nutritional value of these ingredients. If you are talking about meat alternative, the main technology used is still extrusions. And for extrusion, you can think of high moisture extrusion and dry moisture extrusion. Dry moisture extrusion, and I already mentioned it before, is texturized vegetable protein. They are used in many meat alternatives, such as burger, sausage, as it can bring some juiciness, but also some structure to your food. So it's also very, very important. High moisture extrusion for plant-based meat is to some extent relatively more recent. And by high moisture, I mean that you need between 40 and 70% of water at the beginning of your process. And there it's really to get more the fibrous structure, and you're more aiming to the almost ready to eat product. By almost, I mean that you still need some post-processing condition afterwards, post-processing step, but I will come back to it in my next slide. So what you mean what I mean by post-processing is that after the extrusion process, in general, you still need the freezing and thawing cycles, which will help you to get this fibrous structure of the meat. And in general, you need a kind of a marination to bring some flavor, and of course, a cutting to be able to get the shape of the piece of meat that you want to aim for. And this is an example of a Dutch company which is making chicken-like pieces. What you see on the market right now is a chicken-like, pork-like pieces, or spare ribs. These kind of products are upcoming. We have actually a consortia going on right now, which is called Plant Promise. I didn't put the partner on it, but you can contact me if you want to know a bit more on this project. It's a public-private partnership, so it's between the university and several companies along the supply chain. And this project really aims at trying to better understand the structuring of plant protein into the extruder to be able to improve the quality in terms of texture and juiciness. But what we also don't forget is the flavor and the loss of flavor during the process, and how can we limit that, and also what is the effect of structuring on the digestibility of your protein, so on the nutritional value of your final product. As I mentioned already previously, the ingredient selection is very important. Right now, the meat alternative market is really dominated by soybean and wheat gluten. And there is a good reason for it. They are highly functional. So it's in the sense that they are able to form a network, a viscoelastic network into the extruder barrel, and being able to make a firm enough meat structure at the end. There is some drawback sometimes with soybean or wheat. So with soybean, it's an allergen. And at least in America and South America, it is a GMO origin, which can cause a problem, especially in Europe. Wheat, it's also, we have the gluten intolerance. So there is a need to new source. What we see appearing more and more is, for example, yellow pea based plant-based meat. For example, the Beyond Meat burger is based on yellow pea protein. So it is, and lupin is also very interesting protein. The nice things of the split yellow pea and why it's so fashionable to use in meat alternative right now, it's the function that the allergenicity is known, at least there is very little case on this. But the functionality is a little bit lower, so it needs a little bit more formulation work to be able to apply this in food product. Lupin is a very functional protein, but again, it's also on the allergenic list, and I think it's mainly grown in Europe, so it's also not widely available across the world. One of the newer technologies that we have been working on at the Wageningen University and research is the shear cell technology. And actually, this equipment was designed by a colleague of mine, Etienne van der Hout, to actually have a system which is a little bit more organized, or at least in which the shear applied during the making is actually a bit more controlled than in extrusion. In extrusion, it's a very turbulent with a twin screw. It's a very turbulent system, while in the shear cell, you always have the same shear linear flow applied. So it's that you are getting very aligned fiber structures that you see, for example, on this picture, what we call the making of a vegetable steak, where you can see where the fiber are really well aligned, like in a steak. So it's a very interesting technology, and it's what is represented here. That is, the shear flow is very all going in one direction, which allows the making of this aligned fiber. It has some very interesting properties, and there is also a consortia around this technology, which is a milder technology than some extrusion. For example, you go to less high temperature in general. And there is a consortia called Plant Meat Matters, and you can see the partner actually involved in this project. And actually from this technology, a startup recently was launched, trying to aim to bring this technology to the market. So it's an upcoming technology. When you think about plant-based meat alternative, and you may have heard about Nova meat or redefined meat more recently in the news, is about around 3D printing. The advantage of 3D printing is that you are actually printing a fiber, a relatively macroscopic fiber, and that you are able, by printing different layers with different composition, to come with a slightly inhomogeneous structure, a little bit like more meat, which allow different mouthfeel, different final perception of the food. The also advantage is that you can actually also print an inner tube inside the main fiber, which brings you an additional juiciness of the final product. So it's a very interesting, it's still in development. Within this area, we are collaborating with the TNO and the TU Delft to actually to bring this technology further, to be able to print a more complex system in a relatively broad range of product application. So of course, right now I'm talking about meat alternative, but we are also, I've been quite busy in printing chocolate or printing cookie with different formulations to be able to, to further strengthen this technology. What I hope that you got, and I will be open for question afterwards, of course, is that there is a need for the protein transition to make our world more sustainable and being able to feed everyone. What we also see is that there is a need for broader range of plant protein sources, which are suitable for different applications. What we are also trying to really promote is that it's very important for product development to use crops which are locally grown. This will increase really the sustainability aspect, but will also make it easier for you to relate to actually the person growing the starting material. And what we are trying within this consortia setup, it's also to be able to have an integral approach. We are trying to bring on the table people from industry, from the agricultural side, from the manufacturing of the ingredients, for the flavor, from the flavor house, and from the final end product. So we are trying to bring in this consortia these people along the chain to be able to actually involve them in the decision making at each step, because you need the whole chain to be able to agree to have maybe a different fractionation and different isolations to have a specific applications. And as I said several times, every protein is unique. We know still very little about plant protein, also because there is a wide range of sources which are also upcoming. So we need more knowledge around this plant protein and plant protein functionality, especially in applications. So how do they behave in a food matrix? I think it's very crucial for us to be able to go one step further in making our world more sustainable. Okay, thank you. This was my last slide. Yes.
Awesome. I think that was very, very useful and dense with a lot of technical insights, which people are surely going to find very useful. Dr. Laurice, thank you so much for that. Really quickly, I think we can get on to the Q&A section, and we can probably extend by 5-10 minutes since we're slightly running late, but that should be fine. We have a few questions in the Q&A section. Siddharth, would you like to facilitate some of these?
Sure. Thank you, Dr. Pouvreau. Thank you, Swathi. This was a very informative presentation. So there are a few questions, few specific questions, and few broader level collaborative questions. So let me just. So there's a question around microproteins, like how to bind microproteins together when creating a final product. Are there technologies around it, or is it just addition of specific ingredients which act as binders?
Yeah, as I mentioned during the presentation, in the example of the corn product, when the mycoprotein which are from Fusarium venatum, in general, the mycoprotein are mixed with the egg white protein. They are heated together to form a kind of a gel. To gel the macroprotein and the egg white together, and they are frozen. In a lot of these products, the freezing step is very important for actually the final product quality. And after the thawing, they are cut in pieces according to what they want, if they want mincemeat. But egg white or potato protein are used in general as a glue.
Got it. Thank you. I think there was another question around collaboration too. So given, partners can, collaborate with WUR on the product development aspects and developing a product, does this also involve any pilot scale validation or commercial scale validation, or is that something the partner needs to try out on his own, like when the product is being developed?
We do have a pilot plant with the ability to be able to produce some product in a food safe manner, which can be tested by a panel. So we do have the possibility for some application, not for all. We are not equipped for all type of application. And in general, we are really trying to involve the company in this step to be able also for the knowledge transfer. So what we sometimes do is that the project manager or the scientist involved in the translation to pilot scale will go on the site, for example, to actually look at the in the factory of the customer to be able to advise them on which step to take.
Got it. Thank you.
Just a quick addition to that context, and Swathi, feel free to answer that as well. So obviously in India, the products that people are looking at are slightly different compared to patties or, sausages. And accordingly, the flavor, seasoning, and other aspects of the organoleptic properties would differ. And now certainly Wageningen University and your research group has a lot of expertise, which is translatable to, applications specifically for Indian products as well. Have there been in the past similar use cases where you've developed India-specific products? How does that really work, compared to your regular process? Any insights there from either of you would really help.
If it's around the flavor, because as you mentioned, of course, every geography in the world will have different preference in terms of flavor. What we try to, in this case, to involve is a flavor house, which is more local, to help us actually define and design a product with the right flavor. So we try to involve a flavor house because we understand flavor, but we are not flavor house. So the flavor house will have specific, how to say that, specific flavor mix for a specific application, which would be designed for the right country. So it's what we try to do in the case of flavor, for example, is to bring a flavor house from which is more local.
Got it. So for example, Swathi, to add to that point, let's say somebody comes to you with the product concept of a plant-based shami kebab, for example. So how would you go on about facilitating their specific product development project?
Yeah, usually early during the product development, or let's say even when we are discussing the product concept itself, what we try to do is to understand the benchmark, right? We ask for the clients to send us benchmark products from India that our scientists can taste, can sample, and then get an understanding of what we're talking about. We do have a few Indian scientists in-house. One of them has recently joined this year. So she's also able to translate some of these questions from the Indian customers into the final product. So that's quite helpful. But also, I mean, as I said, there are no turnkey solutions because the ecosystem is not quite developed. I can give you this example of a client for whom we made the prototype right before we stopped experimenting with any flavors because they wanted a chocolate flavor. And as you can see, the European chocolate flavors are completely different or not something that the Indian clients would like. So then they took it forward to a flavor house in India in order to further develop the final prototype. So it's a mixed bag, but it also depends on the product itself, So usually either you send us the benchmark samples so we can create what you want, or you take some of the product development steps to India.
Yep, I think that answers my question. I think I'm losing my internet a little bit. Siddharth, do you want to get to the next question?
Sure. Thanks, Shardul. So the next question is around just like development of final products, right? So that we can actually make the final products like plant-based meat, egg, dairy, or fermentation-based meat, egg, dairy products, etc. But can partners also collaborate with WUR to also create just the ingredients? So if I want to create like a fat which can mimic the property of chicken fat or mutton fat, etc. If I just want to create protein isolate from hemp or protein isolate from fava bean, is that also something WUR works with?
Yeah, we are working with ingredient manufacturer and with end user of the ingredient. And when we are working with ingredient manufacturer, in this case, we are more aiming at testing and compare or benchmarking the ingredients against commercial or competitor product and looking at their ingredient. So we can test the ingredient that they have made, but we can also help them improving the functionality of their ingredient. We have a food processing department as well, so that we can combine expertise to be able to help them to design the right ingredients.
Okay, perfect. Sounds good. I think that helps. I think there's another question around just plant-based meat. So, people usually say, hey, we want to develop plant-based meat product, but that could be a plant-based beef, plant-based pork, plant-based chicken. And even within chicken, it could be a chicken breast versus chicken thigh. Like there are so many different textures and flavors associated. So would you have any comments based on your experience on developing all these different types of products? I mean, maybe the technology extrusion remains the same, maybe the parameters change, or maybe the ingredients change. You use one type of protein isolate for say pork versus something else for beef. What are your thoughts around this?
If you are aiming at something like a chicken fillet, yes, high moisture extrusion will always be the one to go, at least right now. But if you are aiming at a more shredded product, or if you are aiming at a burger, you can also think of having the use of texturized vegetable protein as a starting ingredient. And in this case, it's dry moisture extrusion. So yeah, it really depends of what kind of structure you are aiming at. In what we see on the market right now is that the high moisture extrusion is gaining quite a lot of interest because it brings a little bit more moisture to the product and allows more resembling the fiber structure of meat. A texturized vegetable protein would give you a little bit of a chewiness in your product, but will not bring you the fiber structure. At least not as high moisture extrusion would do so. So we see a gain in interest with high moisture right now. Okay.
On that note, actually, yeah, Varun?
Yeah, I had an additional question, definitely on high moisture extrusion, if you don't mind, Shardul. And I think you did as well. You were about to ask a question as well. So Dr. Pouvreau, on high moisture extrusion, this is a key bottleneck for the industry, by the way, that we don't have access to co-manufacturing capacity in India. This is something we're going to be focusing a lot, by the way, to the audience in the Smart Protein Summit. But I just wanted to ask you a question, Dr. Pouvreau. With respect to high moisture extrusion, would you attribute, what percentage of the final product would you attribute to the processing versus the initial ingredients that go in?
It's a $1 million question question. Sorry, sure. It's a very difficult question. I think the ingredient functionality is very important, and it's also why in a high moisture extrusion product you don't see all protein being there used right now. So ingredient functionality is very important, but I do believe that a better understanding of the processing condition, and it's what we are trying to do in the Plant Promise project, would really help to be able to use a broader range of protein. So better understanding which condition, which temperature, which shear and pressure do you need to apply on the beginning, and what kind of cooling you have to apply in the dye is very important to broaden the scope of ingredients. But right now, I think one of the dominating factors is really the ingredient functionality, and it's why you mainly see soy and wheat gluten being used right now.
So we need to improve all aspects of this process all the time in order to get better. Great, yeah. Thanks, got it.
Yeah. Yeah, and it will be really the type of structure that you will get will be really formulation dependent. So of course you have some protein. If you want to have a complete product at the end, you have some fat, which is also included. To some extent, you cannot put too much fat in an extruder. But you also have the flavor, which may have an impact on the structure as well of the final product. And you have the polysaccharides that you can add as well as to help the structure formation as well. So it's also, it's also formulation dependent. So it's an ongoing process to improve the knowledge around this technology.
So, I mean, Shardul, I'll hand back to you for further questions. I just wanted to underline for the audience that we do need to be patient in this industry. We are very much at the beginning of I would say, a decade-long shift, probably more than that if you consider all the business aspects of it as well, which is why when we say at GFI, our overarching goal is to make ourselves obsolete. We would like to accelerate the protein shift, but we will not make ourselves obsolete in the near term. It's just not going to happen. It's very exciting because the optimization on the plant-based side is still taking place all the time. So you're seeing a lot of improved products every year, and still it's going to take a lot of time before we can get the perfect products.
Yeah.
Thank you.
But it's also a little bit logical, I would say. Dairy products are still evolving, and we have been working on dairy product for a century. So it's an ongoing process. It's still a new market, and it's what sometimes people are forgetting. It's a plant-based market is a 20, 30 years old market. So it's a baby still.
Absolutely. I think that ties in very well into our context. I had one quick follow-up question, and again, Swathi and Dr. Laurice, either of you could answer this. Basically, are there any other technologies for texturizing that are currently being worked at WUR, other than high moisture extrusion and other than TVPs, etc., like that could give the relevant texture, maybe in case of fillet, etc., hydrocolloids, maybe, etc. Anything you could point our audience towards. Maybe you could also talk a little bit about the timelines that possibly that they'll have to wait in terms of getting a license on some of these technologies. The reason I ask this is obviously the infrastructure is missing in India. Obviously, one approach is set up a facility for high moisture extrusion and then lease it out to other entrepreneurs. And some entrepreneurs in India are currently working on that. But what about other, approaches that people could take if they want to innovate in this area of plant-based meat, eggs, and dairy?
Do you want to answer the part on the IP, Swathi, or at least the technology and?
Yeah, and maybe we do have something on Shear cell, right? Probably that's the one that is right now being developed and probably will be commercialized in the next 2-3 years. That is one of the technologies that we do see coming out pretty soon. But it also depends on the private partner, right? What sort of market strategy they adopt, and what sort of a licensing technology that they are willing to give away. So in that sense, it also depends on if you want to co-create such technologies with us, right? Then maybe it gives you a better control of taking it to the Indian market. Yeah, I mean, the development levels are at different stages, but maybe Laurice, you can add more on it.
Yeah, as Swathi mentioned, the shear cell technology is something that we are working very hard on, and that it's a consortia which exists for 4 years almost right now, and will finish in a year's time. I'm not going to talk about the IP because, of course, since it's a consortia, the company involved in the consortia have the first IP right. So I'm not. It's a very complicated topic that I will leave to the business people and not to me. But it's an upcoming and it will come. But I still think that for going into the market right now, if you don't want to invest too much into really a specific technology, I still think that the mixing, forming, and shaping is still a very good alternative to actually create good product. And tasty product, which is a more easy way to be able to get into the plant-based meat market, and which help you maybe to make a name for yourself in this area. And as I said, there is a lot of newcomer with the microprotein which are trying to launch. Corn is of course producing microprotein for themselves. They don't sell the ingredient. But you have a newcomer like Biosense or 3FBO, which are also European based, but which are aiming really to sell an ingredient in this case. So you can also think of using these ingredients to be able to go towards a meat type of product. So there is quite some possibilities there in this field.
Yeah, that kind of answers my questions. And just for the audience, the context that I was trying to get at is, okay, a high moisture extruder is going to take some time to become readily available in India. Shear cell technology is probably going to be equally or even more expensive in some cases, possibly, right? But there, like Dr. Laurice said, there are processes, common food processing methods, food engineering methods, which are out there. There's a lot of literature review out there. And then you can tie it up with the specific expertise that, research groups at WUR have in flavors and structures and protein chemistry, and use some of those unit processes to get end products, which are maybe not 100% replicating the texture and organoleptic properties of plant-based meats, but it's 70-80% there. And that's also a great stopgap arrangement which you could explore to, get your products out in the market. Awesome. Any other couple of, I think we can take a couple of questions from Siddharth, and we can then, end this webinar.
Yeah, Shardul, so I'm taking a look at the questions. I think there's a question on the fats that are used in creating plant-based meat products. Dr. Pouvreau, through your experience, if you could just talk about, the fattiness and the flavor of the plant-based meat products, and how difficult is it to attain as compared to attaining the texture?
The juiciness is still something which consumers are giving as a bottleneck in a way, things that they would want to see improvement. In general, the plant-based meat will always be a little bit drier while consuming, so after the baking, than the original meat. So it is something that we are working on to be able to improve the juiciness. And it's partially fat, it's partially more watery perception. What we see in terms of fat is that quite often it's deflavored coconut oil or palm fat which are used because you need a little bit of this solid fat at room temperature for the appearance of the product, because what I did not mention as well is that the appearance of the product that you buy is also very crucial, not only the taste and the texture while you are eating it, but also the appearance. So the solid fat helps for this meaty appearance. And in terms of flavor, what we see and also what we hear, but it's more a complaint from the end producer of the meat alternative, is that the amount of flavor, which needs to be added, and the flavor are quite often dispersed in the fat phase, is quite high. And this is due to the fact that a large amount of the flavor in general is lost during the processing and during the cooking and the making of the food product. So there is also quite a lot of room for improvement there to be able to find a ways to prevent loss of flavor during the making of the product and use less of flavor. So yeah, I hope it's answer.
Yes. Thank you for the answer. So, I mean, there are challenges, but there are also ways to solve those challenges or approach those challenges to get, better final product.
Yeah, no, there is ways, but what I meant, I'm a scientist, so I'm always trying to improve things. It's part of my well-being, I guess. There is ways to be able to have a juicy product and a tasty product, and you have quite a lot of them which are juicy and tasty. But I think the next challenge for the whole plant-based meat is also to have to be nutritious as well. And this is the next challenge for us, because there is ways, but they are not always the most healthy ways to do so.
Absolutely. That's a great insight. I tell everyone, I think we should start by solving for price and taste, and then get to nutrition a little later in your, product launch cycle, because those iterations usually come with slightly more complications of balancing ingredients versus costs, all of those factors. But I think, Siddharth, we can end the webinar here. I'm really thankful to Dr. Swathi and Dr. Laurice for taking the time today and presenting to us and, our community of smart protein innovators about some of the initiatives that WUR currently has. I think a lot of them will have questions for Swathi as a follow-up. And I would recommend everybody to, directly get in touch with Swathi. If there are major and strategic projects that you want to work with WUR, you can facilitate those through us as well, and I will be happy to connect you with Swathi and her team. Like she said, they take multiple different approaches for, whether it's product development, whether it's working on co-developing a technology or licensing technology, and we'll be happy to facilitate some of these discussions going forward. Varun, any closing thoughts? Siddharth?
General thoughts are, this has been super informative. Thank you so much, Dr. Laurice and Swathi. My apologies for the people riding motorbikes in the background. This is just how it's been for us during this time of COVID, all working from home. But yeah, thank you so much for your time. This has been very instructive. This webinar is going to go out to a lot of people in addition to whoever has already attended. We're going to use it also as introductory material for Dr. Stacey Pyatt's session at the Smart Protein Summit on October. I believe she's speaking on October 8th. I think we've confirmed that. And yeah, I think all of this makes me quite hopeful for the future, because I think not only is there so much progress that's already been made in the protein shift, but there's also so much exciting stuff that's on the horizon in terms of new technologies and new things that are going to make even better products. So thank you for enlightening us today.
Yeah, most welcome. It was a
Thank
pleasure
you.
to speak.
I would actually just close out by saying that I ran a quick poll, and 94% of the 200 odd attendees we had at a time found it really useful. About 80 rated it to be very informative to, highly informative. So it's really, I'm really happy that people found it useful, and this was productive for all of us. Thank you for your time. Have a great day ahead,
Many
everyone.
thanks. Many thanks. Yeah.
Bye. Have a nice evening, all of you.
Thank
Take
you.
care,
Bye-bye.
everyone.
Thank you.
Bye.
Bye.
Thank you, everyone.